All right, so in this exercise, it's going to be the first one where we start to really focus on writing code to test the rest of our code, or code to actually automatically check whether our program is functioning correctly. And of course, the word automatically is a little bit of a loaded term. We actually have to do the effort of writing the code, but the nice part about it is that we can rather effortlessly run a lot of code over and over again that continues to test the same test cases. So in this example, we're going to use functions as a way to sort of separate out the work and actually write these tests. The bulk of the program really is about just kind of finding substrings, which is a fairly easy task for string manipulation in Python. So I want to write a function called isIn that accepts two strings as arguments, and it returns true if either string is a subset of the other. So if either string exists in the other, and false if otherwise, right? So it turns out in Python there's an in operator for the string data type that makes it very easy to determine whether a string A is a subset of string B. We can just say is A or if A in B. But to do this correctly, we need to go both ways, right? We need to say if A is in B or in B is in A. But before even dealing with that, I'm just going to start by writing a simple function that conforms to sort of the contract that we just discussed. So isIn, it'll take string A, string 1, let's say, string 2, and it's going to return whether or not string 1 is in string 2 or string 2 is in string 1. But for now, I'm just going to return false. All right, this is called a function stub. It's a placeholder. I can now call this function anytime I want. It's always going to return false no matter what, but at least it's there, and I can start to kind of build my program around it. Now I could run this program and test it by having forcing myself to continue to type in lots of test strings, right? But that's cumbersome, and it's not really all that effective. I'm probably going to have to run this a couple of times before I get it perfect. That's the way programming is, and so it's nice to write your test cases built right into the program. So I'm going to create another function called test, and actually I'll write this above it. Write another function called test isIn. And its job is to take a string, two strings, but also take in as a parameter what we would expect to get. What would be the expected result of calling isIn with string 1 and string 2? And inside here I'll say if isIn string 1, string 2 is not equal to the expected result, which is true or false, then I'm going to print a message and say we failed. Test case failed. And I'll print out the inputs, string 1, string 2, and expected and obviously I got the opposite. Otherwise, print test case passed. Okay, so that seems like a lot of effort, but here's where we're going to here's where we're going to save our effort. Right, so we've got this nice little function that will exercise our code. It's going to call isInTest, and it's going to compare the result of this with what we expected and print out a really easy to read, or easy to understand error message. Now, as my main part of my program, I'm not going to really even talk to the user. I'm just going to write some test cases. So first of all, let's do the real easy ones, right? ABC, ABC, that should return true, right? ABC, those are not just subsets, but they're the exact same string. Test isIn ABC, AB, right? So that should return true because this is a substring of this. Test isIn AB, ABC. Notice how our test cases are almost like examples of what our function should do, right? So it actually creates code that's very readable and understandable. What about case? ABC and AB should return false because this is case sensitive. It's a case sensitive comparison. And we could do something to kind of make that case insensitive if we wanted, but that's, I'm going to assume that it's case sensitive. Let's try some more. So let's do ABC and BCD. Right, so something like that, ABC is not a subset of BCD, BCD is not a subset of this, that should be false. And ultimately that's probably pretty decent test case. These are a lot of different combinations, right, of our test cases. We should also make sure that things don't crash, right? So what if we just do, what if we do empty string and ABC, right? Should that return true? Technically, an empty string, would it be in there? That's going to be interesting to see whether Python will use the in operator like that. All right, so first off, let's just run this. And we know that the program's not complete. But we're obviously passing some test cases. And how are we passing some test cases? How does that make any sense? Well, these test cases are supposed to return false, right? So they pass because I always return false here. But I'm returning, I'm having test cases failed. And of course, it's not very concerning, right? All right, so first let's build this. So we'll check for string 1. So if string 1 in string 2 return true. Else return false. All right, now automatically when I run this, I'm going to get more test cases passing, right? So I'm making incremental improvements. The first test case where string 1 is in string 2 passed. Notice that the in operator does work the way we kind of conjectured or we predicted. The empty string is in another string, right? So this worked. We do have a test case failed though, because in this situation it's not that ABC is in AB, but it's AB is in ABC. So we're still failing there. I can implement that part. Okay, and I get it to work. At this point, now all my test cases are passing, right? And now I should start to think about, well, can I improve the code? And certainly, since I'm returning true in both of these cases, this is fine. I can combine these maybe, so I'll do string 2 in string 1. Right, so that's a little quicker. I can rerun this, and you'll notice actually I did make a mistake here, right? And let's classify this mistake. This mistake is called a regression error. It's a regression bug, meaning I was in a good state and I made a change that I thought would optimize this. I hope it'd make it a little bit more clear. But I messed up. Now here's the real value of having test cases, right? I'm automatically, every time I'm running that program, I'm automatically always checking all 6 of these conditions. I can't tell you how many times, if I have not written test cases like this, that I go to write an optimization and I make a small mistake and I maybe manually test with maybe one of the previous values and it works, like this one, right? But I never actually, I'm usually pretty lazy and I usually don't test all of the conditions. This is where having the test code in your program already baked in reaps a lot of dividends, or it pays a lot of dividends, because you can't be lazy. Every time you run it, you're running the whole battery of tests and you're doing it instantaneously. Now, what's the error that I made? Well, in order for this to be true, both string 1 has to be a subset of string 2 and string 2 has to be a subset of string 1. That was true in the case of this. I still had false because I expected false, so that was okay. But for the other ones I was failing. It should have been or. I can rerun my test. Okay, now they're all passing again. Good. If I want to get even more fancy here, I can just do return the result of this expression. All right, so string 1 in string 2 returns a Boolean. String 2 in string 1 returns a Boolean. The OR returns a Boolean, is in returns a Boolean. And again, I can do that. Whoops, I need to get rid of the colon. I can do this with, sort of not a lot of concern as to whether or not it's going to break things. Every time I run it, I can make sure I'll visibly see all those test cases. So if you've coded up enough test cases in your program, it really frees you from the wondering whether or not specific little changes are going to break your code. You can always make small changes and rerun the entire battery of tests.